Look at the numbers for a moment. Global temperatures rising, carbon dioxide increasing, ice melting. This isn't opinion, it's measurement. Climate change is not defined by headlines, it's defined by data. Let's start with the most important number: carbon dioxide. For thousands of years, atmospheric CO2 stayed relatively stable. Then, after industrialization, it began to rise sharply. This increase was first measured clearly by Charles David Keeling, whose data showed a steady, year-by-year rise in carbon dioxide levels. That curve didn't fluctuate randomly, it climbed consistently. That was the warning. Now let's connect this to temperature. As greenhouse gases increase, more heat is trapped in the atmosphere. Global average temperatures rise. Oceans absorb heat. Ice melts. Sea levels rise. This isn't future prediction, it's already happening. Heat waves are becoming more frequent. Rainfall patterns are shifting. Floods and droughts are intensifying. These trends are confirmed repeatedly by global climate datasets. Now zoom out. Climate change isn't just an environmental issue, it's a systems issue. Energy systems are affected. Agriculture becomes less predictable. Water security is stressed. Infrastructure faces higher risk. Insurance costs rise. This is why climate data now shapes economic planning, urban design, and national budgets. At the global level, climate data is assessed and reviewed by organizations like the United Nations through scientific bodies such as the Intergovernmental Panel on Climate Change. These assessments don't produce opinions. They synthesize thousands of peer-reviewed studies to evaluate risk, uncertainty, and future scenarios. Their findings guide climate agreements, energy transitions, and long-term investment decisions across the world. Now here's a critical distinction. Climate change does not mean the climate changes uniformly everywhere. Some regions warm faster, some experience heavier rainfall, others face prolonged drought. The data shows increased variability, not just warming. And variability is what systems struggle with. Food systems rely on predictable seasons. Cities rely on stable infrastructure. Economies rely on manageable risk. When variability increases, costs rise. Before we end, zoom out one last time. Climate change teaches a hard lesson. Small changes, when sustained over time, reshape entire systems. Environmental science exists to measure those changes accurately, understand their consequences, and design responses based on evidence rather than reaction. In the next episode, we'll focus on air pollution, where we'll separate local pollution from global climate change and see how data helps governments protect health while managing economic growth. This series is part of the Learning Studio, where complex global challenges are explained using evidence, logic, and real-world data. This isn't about belief. This is about what the measurements show.